Hi, this is Dave Liebel, and I'm going to do a second example of a dependent source. This is going to be a dependent current source. So that's a current source there. There's an arrow drawn inside of a diamond. And I'm going to assign this as having a current that's equal to some gain, which I'm going to call 5. 5 might be my beta. So beta equals 5. Times IB, and IB is the current here. So this current source, for some reason, is monitoring the current in this leg and increasing its value to 5 times that current. And when you analyze this circuit, you might notice there's a voltage source here. It turns out that if you try to analyze a dependent source and there's no voltage source or current source, no independent source in the circuit, that usually your current will resolve to 0. And essentially it doesn't work because it needs an independent source in the circuit somewhere. You can analyze these circuits by putting a fictitious source somewhere, like across these terminals, and generating a current. And with that fictitious source, you can analyze the entire circuit, and then set that source equal to 0 and see what it is. But you'll see that the current always goes to 0 in the absence of an independent source. So you might want to try that. You might want to analyze the circuit this way and then take away the 10 volts and see what happens. It doesn't matter where the dependent variable is in the circuit. If there's no independent source, it just won't work. So in this circuit, I have a 10 volt supply, a 25 ohm resistor, a 20 ohm resistor, a 50 ohm resistor, and a current source that is 5 times this current. So I start by writing, and I should show you over here. So I released this video with a sign error in my equations. And of course, in the last problem, I checked that my solution was correct by summing the voltage drops around each loop. And if they sum up right, then you're probably doing something correct. You probably got the right answer. Because if you solve for currents and then they don't, if the currents satisfy Kirchhoff's current law, but they don't satisfy Kirchhoff's voltage law, then your answer has an error. And I did not check. So I did this circuit originally in a video, and a couple hours later, a student told me that this had an error. So I'm posting this video to correct that error. It was a sign error. And it's my fault because I didn't check my answer. So check at the end. You either need to go around this loop, or in this case, I noticed that since this is one node, if I find this voltage, it should equal this voltage. So V25, the voltage across that resistor, 10 volts plus V25 should equal V50, the way I've drawn it. And I'm going to write in a current here, I25. And I wrote this current IB because that's my reference current in that direction, causes this source current. But the I25 I could have drawn in either direction. I just have to make sure I apply Ohm's law correctly. So I start by writing my Kirchhoff's current law. And Kirchhoff's current law is the sum of the currents leaving the node equals 0. So I have I25 leaving the node minus 5IB going into the node plus IB leaving the node. And this is minus 5IB plus IB. That should be the same B. Sorry, sometimes I do that. And so that's I25 minus 4IB equals 0, and I25 therefore equals 4IB. And that was my original mistake. I had a negative sign in here when I did it before. Some of you may be seeing this for the first time, so you won't have seen my mistake. But nevertheless, going around this loop, going into the minus terminal, I have minus 10 volts, minus 25 times I25, minus 20 times 5IB, plus VB. VB is the voltage across this this dependent supply. So it's just a variable I'm making up. I happen to know, having done enough of these problems, that the VB disappears. So when you have a dependent source, you can make up a current if you have a voltage source, and you can make up a voltage if you have a current source and solve for it, but it'll disappear from the equations. So plus VB. So this is my first equation. When I go to my second equation, so I went plus VB because I was going into the plus terminal, but now I'm going to go this way, and I'm going to have minus VB plus 20 ohms times 5IB. and then I come down through the plus terminal, so it's plus 50 times IB equals 0. And so those are my three equations, and you'll notice I have as variables VB, IB, I-25. If I just add these two equations together, the VB will disappear, which is handy. And I'll be left with two variables. And one of these variables is solved by the current equation because I-25 equals 4IB. So I'm going to do this. I'm going to substitute the Kirchhoff current law equation into the Kirchhoff's voltage law equation, the first one, to get rid of I-25. So I'm going to plug this in here. And this becomes minus 10 minus 25 times 4IB instead of I-25. Minus 100 IB plus VB equals 0. Now I'm going to add this equation to this equation. And that gives me 100 IB plus 50 IB minus 10 volts minus 100 IB minus 100 IB. Actually, I think I added KVL2 plus KVL1. Not in this order, but in the opposite order. It doesn't matter, obviously. This reduces to minus 50 IB minus 10 volts equals 0. And solving for IB, I get IB equals negative 0.2 amps. I-25 is 4 IB, so I-25 is negative 0.8 amps. Therefore, the source, 5 IB, is equal to negative 1 amp. Now to check, I said I'm going to check that this voltage plus this voltage equals this voltage, because that's all one node, node X. And so the voltage from node X to C, I call this point C, is either V50 or it's V25 plus 10. Because they're both in the same direction, so they're added. So 10 plus V25, V25, I solved for right here. It's 25 ohms times I-25, so it's negative 20 volts. So 10 plus negative 20 is negative 10 volts. That's negative 10 volts from here to here. So it's a drop of negative 10. And V50 is 50 IB, which is negative 10 volts. So that's also a drop of negative 10 volts from here to here. So it's a drop of negative 10 volts, otherwise known as a rise of 10 volts. And they equal each other, and that checks your answer. Okay, so that's the second example. That's all I got on that one. Thank you.